Now we look at something about the relationship between small g and capital G. So far we have an idea about the acceleration due to gravity, which was denoted by small g, and the universal gravitational constant, that is capital G. Here how these two can be related, that is what we are going to look at in this particular concept. For that sake, what I have done is I have taken Earth. Mass is given by capital M. On the surface of the Earth, a small body of mass small m is kept, and now the distance from the center of the Earth and the mass of the body, center of the mass of the body is, let us say, some small r. So see here, r is approximately equal to capital R, because of the reason the radius of this body is negligible as compared to the radius of the Earth. That is the reason the net distance from the center of the Earth to the center of the body can be considered as capital R. Therefore, according to Newton's universal gravitational law, we have F is equal to G m1 m2 by r square. This is the law, universal law. Here F is nothing but the force with which the body is attracted towards the ground. That can be given as mg, as our diagram suggests, that is equal to G. m1 is nothing but mass of the Earth, that I can write as capital M, and m2 is nothing but mass of the body divided by the distance between these two bodies we have considered approximately equal to the radius of the Earth itself. Therefore, r square, capital R square. So here mass and the mass will get cancelled. Therefore, I will be getting G is equal to Gm by r square. So which gives the relationship between acceleration due to gravity and universal gravitational constant. This is one of the important equations where you can find the value of G if the mass and radius of the body is known. As an example, the mass of the Earth and radius of the Earth, the gravitational constant, all these are constants. If at all you substitute the values of these things, these constant values over here, on the surface of the Earth, G comes out to be 9.8 meter per second square. This is how you can calculate the acceleration due to gravity for different planets, provided the mass and radius is known. Anyhow, G is a constant. So this is what the relationship between small g and capital G. We can also now look at the difference between mass and weight. So what is the difference between mass and weight? See here, mass is nothing but the actual matter contained in a body. So to define the mass, we will be writing this as the actual matter contained in a body, which has certain volume, and occupies some space. So anything that occupies some space and has certain volume. For example, if I consider a body like this, here you have the materialistic particles. It is made of some materialistic particle. If I consider the cotton, these are all the cotton fibers. The cotton fibers together forming a cotton ball. Here, this is the mass. Mass of the cotton ball is something. So what is the actual content in that? And mass never changes. Mass is independent. Mass of a body is independent of place or a planet. So on every planet, the mass of the body remains same. It is not going to change. Whereas the mass of a body changes. That means weight of the body changes. Mass does not change. Weight of the body changes when you are taking from one planet to the other planet. Meaning that if you take the Earth, if a body is kept, let us say its weight is W1. So if you are taking the same thing on the moon, if you are taking the same body on the moon, its weight is going to be W2. and where W2 is less than W1, meaning that when you are taking a body from one place to the other place, one planet, here Earth is a planet and here it is a satellite, you are taking from the surface of the Earth to surface of the satellite. So here mass of the Earth is greater than mass of the Moon. Therefore, definitely the weight of the body is more on the Earth compared to the Moon. And this weight is nothing but the gravitational pull. That means G value is more. G on the Earth is more than G on the Moon. That is the reason, as G is increasing, mass remains the same, but the G is changing. Hence, mge is definitely more than mg Moon. Therefore, weight on the Earth is definitely more than weight of the Moon. That means you need to remember that you have to have a distinction between the mass and weight. Mass is the actual matter contained in the body, which is not going to change from place to place or from planet to planet. Wherever you take the body into the universe, the entire universe, mass remains the same. Whereas weight is changing. When you are taking a body from one planet to the other planet, weight is going to change. As an example, here we have considered when a body is taken on the surface of the Earth, its weight is W1. When it is taken on the Moon, its weight is W2, meaning that the Earth is pulling the body with some force. That force is called as the weight. So weight can be defined as the gravitational force acting on a body. That is the reason W can be represented as mg. Mg in the sense F is equal to ma here, A is replaced by G, which means the gravitational force with which a body is attracted towards the surface is called as the weight. That is the difference between weight and mass. So weight is product of mass and gravity. Here mass is the material contained in the body. That means actual content, and it is nowhere concerned with the place where it is placed, where it is taken to. That means everywhere the mass remains same, but weight is changing depending upon its gravity values. So gravitational pull or acceleration due to gravity on Earth is more than acceleration due to gravity on the Moon. That is the reason obviously the weight of the body on Earth is more than the weight on the Moon. Same body, same massive body I have taken, but weights are differing. Masses are not differing. So mass here is same as that of mass here, but weight here is more than the weight there. This is how you can distinguish between the mass and weight. So weight is a force experienced by the body when it is placed on a particular gravitational influence. Mass is nothing but actual matter contained in the body. This is how the distinction takes place.